Hello, I'm going to talk about the difference between a 2-wire and a 3-wire wiring configuration, particularly for agricultural valves, which TIR handles both solenoids and motorized, which use both 2-wire and 3-wire configurations. It's a topic that comes up frequently, so bear with me and I'll cover both from a diagram standpoint and then from a practical application standpoint to hopefully give you a better insight as to 2-wire or 3-wire configurations. So starting with the 2-wire, it's as simple as it sounds. We have a wire that comes off of the positive. It will run through a switch. It will go down through a device, either a pump, a solenoid, a motor, or some other 2-wire application. In this case, a solenoid. It'll go through the solenoid, come out the other terminal, and return back to the ground. So when the switch turns on, the power flows through the solenoid, we create work, and it goes back to the ground, and we have a completed circuit. So in the application world, if we take our standard solenoid, we hook a negative wire to one terminal and a positive wire to the other terminal, and we turn the unit on. You'll see our amperage jumped up to about 1.8 amps. So if I take this plunger and spring and I push it up inside, it draws it up and we have work. Release it, it pops out, draws up, pops out. To show you what 2 amps of work looks like, if I take this and put it in, actuate it, I can't pull the steel rod out of a standard solenoid with 2 amps worth of work. Now, that's going to generate a lot of heat when it's in that active phase. So TIR came up with a solution, which is use a computer chip to drop it down to the amperage we actually need to create the work. So when I flip the switch, we have the 1.8 show, and it drops down to about 10%. The steel is in the solenoid, it's not coming loose, but I can actually pull that loose with some force. It's reattached, but I can pull it loose. That reduces the amount of heat that this particular solenoid is going to draw and create as it's operating because of the big amperage drop. Now in a 3-wire configuration, such as a motor, and I'm going to use a TIR motor valve for this demonstration, but to run through it very quickly, the 3-wire setup is exactly as it sounds. We have one wire, it's going to run through the switch again, and it's going to be soldered down to a circuit board. We have another wire coming off of the positive, and it's going to run directly to the circuit board. And then we have a third wire that runs from the negative or ground, and it's going to run down and be soldered directly to the circuit board. What's important to understand about 3-wire setups is they're going to use either a relay or a transistor to hold the device in an on state, and that's going to reduce the amount of current that the unit is actually using, but it is greater than 0. Do understand that. So the device in this case is actually a TIR motor, and the wiring configuration is important to understand, and I will show you why at the very end of the video. But for TIR, the center pin is going to be the negative, the right pin is going to be the positive. I can get this in there, and then I have a full-time 12 coming off of my power source, and that's going on the left pin. So the motor hasn't actuated, it's off, we have 0. I actuate the motor, there is 12 volts available there, and now the amperage is showing 0.01. If you noticed and watch it as it actuates, it'll jump up to about 0.25 or 0.3 and then drop down to either 0.01 when it's on or open. I close the valve and it goes to 0. I open the valve, the 12 volts is needed to actuate the motor and then hold this circuit in an on state. I turn it off, we still need the 12 volts to actuate the valve, but then it turns off the power completely. Now, one quick thing that people will call with, they say, look, My valve, I've got it hooked up and wired. I think it's right because it will actuate, but it won't, the switch won't actuate it. So if I reverse the positive and the switch, the motor just turned, but the switch doesn't do anything. I can pull this off, I can put it on. It will not actuate again. The reason for that is the 12 volts is now keeping the circuit live. As you can see there is 0.01. I removed that. It still didn't reduce anything. So I put the 12 volts on the negative, and that re-energizes the circuit to send it back to 0. So that's the difference between a 2-wire and a 3-wire, and a quick check for if your valve will only open to try reversing the leads, because most likely you've got your 12 volts holding the circuit in the open state.
Texas Industrial Remcor, quality valves and controls today and tomorrow.